Today's lesson is going to be on types of centers of circles or points of concurrency in circles based on triangles. And so the first thing, centers and triangles based on circles and different pieces and parts we've already talked about. So the first thing you need to know is concurrent lines they're concurrent if they intersect at one point and it's three or more. So not just the intersection of two lines, but the intersection of three lines at any one point. Okay, and so the first type of center we're going to talk about is a circumcenter, and that's when you find the perpendicular bisectors of all three sides of a triangle, and they should be concurrent and equidistant from the vertices. Okay, and so you know it's a circumcenter because you can circumscribe a triangle or a circle around the triangle, which means you can draw a circle around the triangle that goes through all three vertices. So really that point is going to be the circumcenter, as if we're trying to find something that's the same distance from all three vertices. And this is actually a pretty useful thing in real life if you're trying to find the same distance from all 3 points or 3 different things, and people will use it when deciding where to build a grocery store or where to put a cell phone tower or things like that. Okay, the next one is the incenter. The incenter is created by creating the angle bisectors of the triangle, and they should all three be concurrent at a point that is equidistant from the sides. And it's called the incenter because you can inscribe a circle, so you can draw a circle inside of the triangle that is the same distance, or hits all three edges of the triangle inside of the triangle. Okay, so this would be like if you're trying to fit something into a triangular space, this could tell you the best place to put it. Okay. And so circumscribed about means that circle is drawn through all three vertices on the outside, and inscribed is inside of the triangle, and it will touch all three sides of the triangle if it's inside. Okay, so then we can use those and talk about different things we can figure out. So if I wanted in a library to be built the same distance from all three towns, that would be something that I would use the circumcenter for, because I want it to be the same distance. You could think of those as the three vertices of the triangle. So a circumcenter would be the best way to figure that out, okay? If I was looking at this next one and there's 3 snack carts, and they want to have the same distance from the yogurt distributor, we want to find the distributor inside. Let's see, each of the 3 carts is the same distance from the frozen yogurt distributor. Find the location of the distributor, okay? So these are also the vertices, and we want something that's the same distance inside of that triangle from all 3 vertices. We're still going to use the circumcenter for that again. Okay. On the other hand, if we had a triangular backyard and they wanted the largest possible circular pool in their triangular backyard, we would decide where that was located by using the incenter, because we want it to be inside of that triangle, okay, that center point inside that's the same distance from all the sides, not the vertices, okay? All right, so then there's one other type of center we talk about finding, and that's the centroid. But we find that by creating these medians. So you create all 3 medians, and so the medians are when you take the vertice and connect it to the opposite midpoint of the side, like across from it, okay? So this would be a median. So we're taking it from this vertice to the midpoint of this opposite side, okay? And if we create all the midpoints, all the medians, then this is the centroid, okay? And something really, really, really important about the centroid is that it is 2/3 the distance from the opposite side. So like JC is 1/3, and then CD is 2/3, okay? So this point from C to the vertice is going to be 2/3, and then from C to the side is going to be 1/3, okay? It's also called the center of gravity, the centroid is. It's because it's where if you put your finger there and you tried to balance a triangle, the centroid would be that center of gravity, or the center of balance, okay? So now we're going to use all the different centers of these triangles and answer some questions. So the first thing is we want to find something that circumscribes triangle XYZ. Okay, so Circumscribes is going to be the circumcenter, which means we are going to find the perpendicular bisectors of all three sides. YX or XY is vertical, so we know perpendicular is going to be horizontal, and it's 1, 2, 3, 4, 5, 6, and so we know it's going to be at 3. So this is the perpendicular bisector of that side. Okay, 1, 2, 3, 4. YZ is 4 long, horizontal, so it's going to be a vertical line at 2. Okay, oh goodness, straight lines. So we already know that this should probably be the circumcenter, but we can also find the perpendicular bisector here of YZ, and we would find that by finding the midpoint, okay? And so the midpoint from here to here is going to be right there, and you can do the midpoint formula if you would like. Or you can look at this slope and say, oh, okay, the slope goes 1, 2, 3, 4, 5, or sorry, 1, 2, 3, 4 across. 1, 2, 3, 4, 5, 6. So it's 6 over 4. So that slope is negative 3 over 2. So if it's going 6 over 4, I can go half of that, which is also negative 3 over 2, and get this point right here. And then do the opposite reciprocal and go up 2 over 3 and get that line there. So this point right here will be the circumcenter. And again, that is found by finding the perpendicular bisectors. Always find the perpendicular bisectors. So if you wanted to go through to find the perpendicular bisector that is not vertical or horizontal and do that, the steps that we talked about yesterday, you could do it that way. So the circumcenter on this is at the point 3, 4. Okay, on this one, we are looking at this, and I see right now that we have some perpendicular lines, but there's some angle bisectors here. Oh, look, these are the angle bisectors, and they're intersecting at point Q, so I know this is the incenter. Okay, and so I know it's the same distance if I inscribe a circle. Oh, that is a very beautiful circle from all the sides. Okay, so QM, QN, and QP should all be the same length. So these inside to hit the sides, because a circle, this is the circle, the center of the circle, which means these are all radiuses, and they're all going to be the same length. So I can set these two that I know equal to each other. So 3x plus 8 equals 7x plus 2. I can take away 3x from both sides and get 4x plus 2. Take away 2 from both sides and get 4x equals 6. And then divide by 4 and I get x equals 1.5. Okay? But that's not what it's asking me. The question says to find the length of QP, okay? And again, since this is the incenter, we know QM, QN, and QP are all the same. So I'm going to plug into either one, QM or QN, and then I can get the length of QP because I know it's going to be the same. So I'm going to do 3 times 1.5 plus 8, and that's what QM is. Okay, and so 3 times 1.5 is 4.5. Plus 8 is 12.5. Okay, so I know that QP is 12.5. I could also plug it in for QN and do 7 times 1.5 plus 2, and I should also get 12.5. And you can check that if you would like. And you should also get 12.5. Okay, for this next one, we're going to see that we're going to do the medians here. And we're going to use those and know that it's the centroid and use the 2/3 relationship. And so the medians that are drawn in triangle PSV are the ones that are going from a vertice to the opposite midpoint. So SY is a median. And from this vertice to the opposite midpoint, PX is also a median. Okay, so we know that where these two intersect is going to be the centroid. Okay, and the third one would intersect there if we drew it in as well, but it's not on this picture. And then we're going to use that piece of information, and then we're going to figure out these missing pieces. So it says if SY, so if this whole length here, SY, is 15, then what is SM and MY? Well, we know that SM is 2/3 because it's going to the vertice. So this is 2/3 of the distance, and MY is going to be 1/3. So we know that SM is 2/3 of 15, which is 10, and MY is 1/3, which would be 5. Okay? We're going to use that same relationship on the next question, and it says that MX is 14, so just this piece here. We want to find PM and PX. Well, MX here, this is our 1/3 because it's the one that's connecting to the side. PM is going to be the 2/3. Okay, and then this is the whole thing, or 3/3. So if MX 1/3 is 14, then PM is going to be 28. And PX is 3/3, so we're going to multiply that by 3 and get that PX is 42. And again, that has to do with the fact that these medians have a 2/3 to 1/3 relationship. So this is 2/3 and this is 1/3. The 2/3 is always the part that connects to the vertice, and the 1/3 is always the part that goes to that midpoint. Okay, same thing here. MY, that's that 1/3, and SM is that 2/3. Okay, so you have to use that relationship to then find those missing pieces. Okay, the last thing we're going to do is we're going to find the coordinates of a centroid of a triangle with the vertices 2, 5. So right here, 4, 9, and 6, 1. Okay. So again, draw this triangle in here, and we need to find the medians. Okay, so you need to find the midpoints between each of these, and you can do that graphically, or you can do that using the midpoint formula with each. But if I do it graphically, what I would do is say from this point here, I would go down 1, 2, 3, 4, 5, 6, 7, 8, and go over 2. So instead of going down 8 and over 2, I would go down 4 and over 1, and that's going to be the midpoint. So this is our first median. Okay, I'm going to do the same thing here. This one's going up 1, 2, 3, 4, and over 2. So I'm going to go up 2 and over 1, and then I'm going to connect and find that median. And then we'll do the same thing here, 1, 2, 3, 4, and over 1, 2, 3, 4. So we're going to go down 2 and over 2, and so this is the midpoint of this side, and I'm going to connect it to the opposite vertice. And we get that that point right there is our centroid, which is the point 4, 5. And that is created, or we find that by the concurrent point, where all the medians are concurrent. So they all three meet at that point, and that's the center of gravity. Okay, you have a formative assignment to go with today. So go ahead and look over the notes, copy down the notes, make sure you have all the different types of centers of triangles and how to find them, and then go ahead and do that formative.